Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I will be going over some example problems of how to get the K value from for an unknown reaction, or an unknown K equilibrium constant from a known equilibrium constant from a different reaction. So in these problems, you're going to have to know the relationships of the equilibrium constant value to the manipulation of the equation itself. So remember that if you reverse the reaction, you have to take the inverse of your equilibrium constant. So you got to flip it, right? So you got to take the inverse of it, or put it over, or put it under 1 to get the new K value. If you multiply your equation by a factor, then you have to raise your K value to that same power. So if you multiply your equation by 2, then you got to raise your original K value by a power of 2. And the third relationship is if you add equations together to get a resulting equation. The K value, the equilibrium constant for that resulting equation, is going to be the multiplication of the K values, the equilibrium constants of the equations that you added together to get your resulting equation. So those are the three relationships that you need to remember. And so I'm going to use those to help do these problems. So the first problem is I have nitrogen gas plus hydrogen gas is going to form ammonia. So for this reaction, I'm giving the K value 5.6 times 10 to the 5. Okay, and then they want to know, okay, well, what about this equation here? Like, what would be the equilibrium constant for that equation? Well, I look at the one that they gave me and I say, okay, well, how is this related to this one? And right away, I notice that NH3 is a reactant here, but it's a product here. And then nitrogen and hydrogen are products here, but they're reactants here. So that means I have to flip the equation to, this equation, to get this one, I have to flip this one. So if I flip this, then what that tells me is I need to take the inverse of this, or take the reciprocal of this equilibrium constant there. So I'm going to have to take this and put it under 1. So it's going to be 1 divided by that K value. Okay? So that's the first thing I need to do. So I need to flip this equation. And then the next thing you'll notice is that I have a 2 here, but I have a 1 here. And I have a 1 for the nitrogen, but I have a 1/2 for the nitrogen here. So, and then I have 3 halves for hydrogen here, but I have 3 here. So what you notice is that everything is divided by 2. So in order to get this equation from this one, not only do I need to flip this equation, but I'm going to multiply this equation by a half. And remember, the rule is if I multiply the equation by half, then I have to raise the power of the resulting equilibrium constant by a power of a half, which means for a power of a half is the same as square root. So I have to take the square root. So to get my answer here, I would have to take this value over 1. So what I'm going to have to do is I'm going to have to, the new equilibrium constant is going to be this equilibrium constant over under 1. So it's going to be 5.6 times 10 to the 5 power. So I took the reciprocal of that one. And not only that, but I'm going to have to raise this to the 1/2 power, which is the same as square rooting. So if I do that, then what I need to do is get my calculator ready. And so I'm going to take 1 divided by 5.6 times 10 to the 5. That's going to be equal to that. Okay, so now I'm going to take this and I'm going to raise it to the 1/2 power, so I'm going to square root it. And my answer is, so the new value is going to be 1.3 times 10 to the third power, negative third power. And so that is the answer to this one. Okay. What about the second one? So in the second one, they're giving me this equation here. I have 2 CFO2 gas going to carbon dioxide gas plus CF4 gas. And the equilibrium constant for this equation or this reaction is 2.2 times 10 to the 6. So, and then they want me to find what's the equilibrium constant for this one. So I want to see how this is related to this. And again, right away I see that I have COF2 as a reactant, and here it's a product. Okay? And also here I see that CO2 or CO2 is a product, CF4 is a product, and these are products as well. So I noted, or these are reactants here. So I'm going from products to reactants, reactant to product. So I need to flip my equation. So the new K value is again going to be the inverse or reciprocal of the old one. So it's going to be 2.2 times 10 to the 10 to the 6. So it's going to be 1 over 2.2. So 1 over 2.2 times 10 to the 6. And then I notice that the difference between this equation and this one is a factor of 2, right? So instead of having a 2 here for COF2, I have a 4. Instead of having 1s here, I have 2s. So this equation has to be multiplied by 2 to get this one. So that means I'm going to have to raise this K value, this equilibrium constant, to a power of 2. So I raise that to a power of 2. And then I do my calculation again. So here, 1 divided by 2.2 times 10 to the 6 equals, and then I'm going to have to square this. So I square it, and that gives me, hold on a second. That's going to give me 2.07 times 10 to the negative 13 power. So that's my new K value for this this reaction. So that's how you do it. I've got one more problem to do, and I'll show you that in just a moment. Alright, welcome back. So this is the third example problem. So in this problem, they're giving me 3 different reactions. And for these first two, for these last two, second and third reaction, they're giving me the equilibrium constants for the second and third. So K2 is equal to 1.0 times 10 to the 5, and K3 is equal to 1.4 times 10 to the 7th. And so they're giving me this equation here, and they're asking me what is the equilibrium constant for K1. So I need to use these two to figure it out. So chances are it looks like I'm probably going to add these together in some way. So first thing I want to do is look at what I have as a reactant and as products and see what lines up here with regard to the products and reactants. So notice here that I have CH3OH as a product here, but I also have CH3OH as a product here. That tells me that I'm not going to reverse this reaction. I'm going to keep it the way it is as it's written. Okay, I might have to multiply it or do something else, but I'm not going to change the direction of this. Okay, so notice here I have CO2 and H2 as reactants here, but I need H2 but I only have H2 as a reactant here, but I have this carbon monoxide here as well. Here I have H2, and here I have CO2 as well. So here, my target equation is CO2 and H2. Here I have CO2 and H2. So I don't have CO2 for this one, and I'm keeping this one the way it is. So this one I'm going to have to flip. So this one, if I flip around, so if I flip this, it'll be CO2 gas plus H2 gas, and then the equilibrium sign or the double arrows, and then I'm going to have CO gas plus 2H2 gas. So double check to make sure I got that right. So CO2 H2 gas plus, oops. Yep, okay, so I'm glad I double checked. So this should be, looking at the wrong one, that should be H2O gas. So it's always good to double check to make sure you're not making any mistakes. All right, so here is, I'm taking this one and I flipped it. So basically I took that one, I flipped it, which means that I'm gonna have to take the inverse of this. So then the K value for this, we'll call this, since we flipped it, we'll call it negative. We'll say K -2 or -2 to mean that we flipped it. And so that's going to be 1 over 1.0 times 10 to the 5th power. Okay. All right, good. So this one we're not going to use, so we flipped it, so we can like ignore that one. Okay, so now we're looking at these two and seeing how these might add to that one. So, and I want to make sure that the coefficients are the same. So if I add these together, and then the next thing you want to know, look at is, can you cancel anything out? So is there anything as a reactant that you find as a product that you can cross out? Because those will cancel out. So here I notice I have my CO, my carbon monoxide gas here, but I also have carbon monoxide gas, and it's 1 each. So I can cancel that out, and there's nothing else to cancel out. So it looks like if I add these two together, right, I'll get my CO2 gas. So I got my CO2 gas there. And I add these two together, that'll give me my 2 and my 1. That's going to be 3 H2 gas. And then I got my equilibrium, double arrow. And then I have my CH3. Here I have my CH3OH gas here. And plus my water vapor. Okay, so these two equations add up to that one. So whenever your two equations add up to your resulting equation, then what you do is you multiply the K values, the equilibrium constants for the two equations or whatever number of equations you added together. So here what I would do is I would take this one, this one here, my K3, so K3 multiplied by K -2 is going to give me my K that I want. So it's going to be 1.4 times 10 to the 7. We're going to multiply that by 1 over 1.0 times 10 to the 5th. And then we're going to calculate that out. And this becomes 1.4 times 10 to the 2nd. So that is the resulting value of our equilibrium constant for this resulting equation, so the one we wanted. And so that's how you deal with these problems. I hope this was helpful. If you like this video, like, share, subscribe, hit the notification bell, and I'll